Hello guys, this is Miss Brito here. Today you guys are going to learn how to find the lateral and surface area of a pyramid. If you read today's introduction for today's objective, you should know what a pyramid looks like or what it consists of. But just to remind you, a pyramid is just a three-dimensional solid which consists of one base, and the base, like if you look at this example here, the base will either be a square, it could be a rectangle, it could be a triangle, a hexagon, any of those two-dimensional shapes that you've seen before. So always identify the base, and it also consists of lateral faces. And in this case, these triangles here are the lateral faces. Actually, every pyramid will always have triangular lateral faces, and all those lateral faces meet on one point, or at one point, which we call the vertex. If you think of the pyramids in Egypt, again, if you were standing in the middle, you can look up and you're gonna see that all those triangular walls meet up there at a point of intersection, which we call the vertex. Now, in order to find the lateral and surface area of any pyramid, I have the steps listed here, and we're just gonna follow them and make sure we follow them the right way, so that we know how to do these problems, or so that we do them right. So here, find the lateral surface area of the square pyramid below. So it's a square pyramid, which means the base is a square. And there is a blue dotted line here, and it is 8 centimeters. And then they gave us a 12 here. So the first step you're gonna do is to identify the base. And in this case, I made the base green. You identify right away because you need to know what it is. And in this case, it's gonna be a square, and the problem is telling you square. And then you're gonna find the area of that base. And we label the area of the base with a capital B. So I'm gonna do the first step. Identify what it is. Or what the base is a square. And then I'm going to find the area of the square, which is also the base. That is gonna be, because they're giving us a 12 here, every side on a square is congruent. So this one is also a 12, this one is a 12, the one on the back is a 12. So the area of a square is either one of the sides squared or base times height, right? And that is gonna be just 12 times 12. Is 144 centimeters. And this is basically our B. Okay, so B equals 144 centimeters. Now, step 2 says to find the perimeter of the base, and we call it P. The perimeter of the base, because the base is a square again, is just the addition of all the sides. So 12 plus 12 plus another 12 plus another 12, or just 12 times 4. And 12 times 4 is 48 centimeters. And now step 3 says to identify the slant height. Very important with pyramids. And before I do this step, I want to make sure that you guys understand what the slant height is. The height of the pyramid is 8 in blue right here, but the slant height is not this one. There's 2 different heights on a pyramid. There's gonna be the regular height, which is like if you were to go inside a pyramid and you're standing right in the middle of it. And let's say you tied a rope all the way up to the vertex, and it's gonna be perpendicular to the floor, then that's the actual height. But the slanted height, you have to measure it from standing right in the middle of one of the triangles outside, and then measure it from the middle of the triangle all the way up to the vertex. And it's slanted. It's not perpendicular, it's slanted. It goes to the side, and we call that one the slanted height. And here is it's gonna be the black line. So identify the black, or the slant height, which is this black line right here, and or segment. And then I'm gonna find it, because we need to find the slanted height using the appropriate theorem. So the best thing to do for this one is basically you're gonna have a triangle in there. I'm gonna just take it out. So I have the blue line. Actually, let me just draw the blue segment right here, which is 8 centimeters. Then I have the black one, just slanted. and I don't know what that is. And then I have this, notice that the height inside is right in the middle. And if I were to draw a segment right here, that will be half of 12. Very important. Half of 12 right here. So this is 6. And now I have a right triangle because I know that the blue segment is perpendicular to the base. And to find the black slanted height, that is going to be the hypotenuse. So then I'm going to use the appropriate theorem. Whenever I have two sides on the right triangle and I need to find the third one, all I need to do is the Pythagorean theorem, that c squared equals a squared plus b squared. Always make sure you don't confuse your hypotenuse with any other side. So I need to find the hypotenuse. That's going to be 8 squared plus 6 squared, or 6 squared plus 8 squared, and these are interchangeable. It doesn't really matter as long as you know that c is the one that goes outside of the sign. C squared equals 8 times 8 is 64 plus 36, 6 times 6. C squared equals 64 plus 36, that's 100. And then c equals the square root of 100, which is 10. Now I'm going to find the lateral area. And even if the problem doesn't tell you to find the lateral area, in order to find the surface area, you always have to find the lateral area, because the surface area consists of the lateral or the triangular faces area plus the area of the base, and all together is the surface area. So to find the lateral area, the formula says the lateral area is going to be half of your perimeter times the slanted height. So I'm just going to plug in or substitute those values into the formula and find the lateral area, and I'm going to do it right here. I have step 4, L equals half of my perimeter times the slanted height. L equals half, or this lateral area equals half of the perimeter, and I found my perimeter earlier to be 48. So 48 times the slanted height, which is 10. Okay. Now I have L equals half of 480. That is 240 centimeters squared. The last step is going to find the actual surface area, which is the sum of the lateral area plus the base area, basically. And this is your formula. Again, this is the lateral area plus the base area. So surface area equals the lateral area, 240, plus the base area, which is 144. And all together, when I put that in the calculator, is 384 centimeters squared. And those were the steps. Okay, so shoot me a text or an email if you have any questions, and good luck with your worksheet.